So today we are going to graph each of these sinusoidal functions. I have this one here and this one here as well. We'll be going through both of those today. And we're also going to find the amplitude, period, vertical shift, and phase shift of each sinusoidal function. Now, in order to even graph the function, we need to find these things anyway. So regardless of whether the questions at your school are asking you to find all these things, it's technically a requirement if they're asking you to graph the function anyway. So let's dive in. Okay, so first of all, it says to find the amplitude. So in this first one here, the amplitude is 5 because the amplitude is always the number that's multiplied by the cosine or sine or whatever it is, right? So amplitude here is 5. Now I recognize there's a negative sign. All that negative sign means, though, is that this graph will be flipped, right? And so when we take into account our original cosine graph, we're going to have to flip it from there and reflect it in the x-axis. But yeah, amplitude is still 5 because it's the absolute value of this number here, which is negative 5. Okay. Next, it says to find the period length. So the period length is going to be 2 pi over the b value. Now in this case, the b value is this value right here, so it's 2. So it's 2 pi over the b value. In this case, that's 2 pi over 2, which is pi. And so therefore, the period length is pi. Then we have the vertical shift. So the vertical shift is indicated by the very last thing we have here. If we don't have anything at the end here, that just means that there is none. But in this case, there is. And basically, it's a translation down 1. And then also the phase shift. There is no phase shift. If there were a phase shift, it would be in these brackets, and there's nothing in these brackets other than the 2. And that 2, because it's multiplied to x, indicates a change in the period length rather than a change in our phase shift. Okay, so now I'm going to graph all of this. So if an entire period length is pi, I'll put pi here and negative pi here. And then I'm going to write everything else accordingly. So this would be pi over 2. This would be pi over 2. This would be 3 pi over 4. This would be pi over 4. Then we have negative pi over 4, negative 2 pi over 4, which is the same as negative pi over 2, negative 3 pi over 4, and negative pi. So we're going to end up just drawing 2 cycle lengths of this. Then we have to take into account, so now we've taken into account the period length. Now we need to take into account the phase shift, or sorry, the vertical shift rather, and the amplitude as well. So the vertical shift is that we're going to be going down by 1. And then the amplitude is 5. And so that means we're going to be going from there up 5 and down 5. So what I'm going to do is I'm going to say, well, let's have each of these be 5. So here's negative 5, and here's 5, 10, negative 10. And keep in mind, we're going to start at negative 1. Normally, we would start at the x-axis. Here, we're going to start at negative 1. So I'm just going to draw a dashed line right here. And I'm going to label it that this is the x equals 2, or sorry, the y equals 2, negative 1 line right there, okay? Because that's where we're going to start and end. So now I'm going to draw the cosine graph, starting right here, because keep in mind that it's being reflected. So starting right here at negative 6, and then we're going to go here to our midline, and then we're going to go past our midline up to 4, then back to our midline, and then back here to our minimum, which that shouldn't be quite that far, because yeah, that's supposed to be negative 6, so right around there is good. And then same thing here. Same thing the other way. And then up to 4, back down to the midline, and then back down to negative 6 like that. And now I'm just going to connect my points like this. And so as you can see, this is just the regular cosine graph, but it's been modified in 3 ways. What were those 3 ways? Number one is the amplitude has changed to 5, right? So we're going up 5 and down 5 from the midline. The midline has changed, right? We translated down by 1, so the midline is now at -1. And then actually, I guess there's 4 ways because I forgot about the reflection. There was also a reflection in the x-axis, so that was a change. And then the last change was the period length. Instead of being 2 pi like normal, this one was only pi. All right, let's move on to the next one. So first I'm going to write the amplitude. So amplitude is going to be 0.5, just because that's the number out front. Then the period length is going to be 2 pi over the b value. In this case, as you can see, the b value is 1/2, so therefore it's 2 pi over 1/2, which is 2 pi divided by 1/2, which is 2 pi times 2 over 1, which is 4 pi, so therefore the period length is 4 pi. Then we have to do the phase shift. Now, a lot of people would look at this and say, oh, the phase shift, it's pi over 2 to the right. But that's not quite right. In order to accurately get the phase shift, we have to factor first. We have to factor whatever this b value is out of both of the terms here. And so I'm just going to rewrite this equation in order to do that. This is 0.5 cosine of 1/2 times x minus pi, like that, plus 1 outside those brackets. So the phase shift is actually pi units to the right. So phase shift is pi units to the right. And then do we have a vertical shift? Yes, we do. We have a vertical shift of up 1. So the vertical shift is 1 unit up. Awesome. Okay, so let's review quickly. What are the changes? The amplitude, instead of being 1, is 0.5. The period has stretched out to 4 pi instead of just being 2 pi. Also, we're shifting pi units to the right and 1 unit up as well. Okay, so let's write all this. So let's let this be 4 pi, 3 pi, 2 pi, pi, negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Let's let this just be -1, -2, and 1, 2 is going to make the most sense here because our amplitude's only 1/2 anyway. Then I'm going to draw my midline. So my midline is going to be here at 1 because we're translating 1 unit up. So there's my midline right there at y equals to 1. Then I have that the phase shift is pi units to the right. So we're going to be starting here at pi units instead of at 0. And then we can draw this. So let's draw it. So we're going to start up here, right? Half a point above the midline as a half, or 0.5 is our amplitude. And then we're going to go back down to the midline. And then down a point from the midline, back up to the midline here. And then same pattern, right? Back down to the midline over here. And then half a tone down, back up to the midline, back up to the maximum, and then back down to the midline over here. And you might be thinking, oh, but this looks like a sine function. And you'd be right. This is the equivalent of a sine function that does not have any phase shift. Okay, so I'm just going to go ahead and draw those points like that. And there we go. All right, as always, feel free to leave any questions you might have in the comment section, and we'll see you for the next one.